Welcome to your practice test 6. Next section. Learn neural network fundamentals. Question 1. During inference, how does a batch normalization layer behave differently than during training? Option A. It uses fixed running, moving average statistics instead of per batch statistics. Option A. It recomputes statistics from the single inference batch every time. Option A. It is removed entirely from the network. Option A. It switches to computing attention. The correct answer is V. In training, batch ROM normalizes using the current mini-batch's mean by variance while updating running averages. At inference, it uses those fixed running statistics for deterministic batch size independent output. Question 2. That causes the dying error problem. Option A. Neurons stuck outputting 0 for all inputs, so their gradients are 0 and they stop learning. Option A. Neurons outputting values greater than 1. Option A. The softmax saturating. Option A. Too small a vocabulary. The correct answer is V. If a reader unit's inputs are always negative, often after a large update, it outputs 0 with 0 gradient and never recovers. Peaky biparametric read-in or careful learning rates mitigate this. Question 3. The double descent phenomenon challenges classical intuition by showing what? Option A. Nest error can decrease again as model capacity grows well beyond the interpolation threshold. Option A. Nest error always increases monotonically with capacity. Option A. Training error grows with more data. Option A. Models cannot fit the training data. The correct answer is V. Double descent shows test error rising near the interpolation threshold, then falling again as overparameterization increases, nuancing the classic shape bias variance picture for very large models. Question 4. Which statements about optimizers are correct? Select all that apply. Option A. Madame the decouples weight decay from the adaptive gradient update. Option Die with momentum accumulates a velocity term from past gradients. Option A. Real prop scales updates by a running average of squared gradients. Option A. Madame never uses any estimate of past gradients. The correct answers are V and A. Madame the decouples weight decay, Y plus momentum uses velocity, and real prop uses squared gradient averages. Madame explicitly tracks moving averages of gradients and their squares. Next section. Transformer architecture and attention. Question 5. During autoaggressive decoding, the YAG cache memory footprint grows roughly proportional to which factors? Option A. Sequence length times number of layers times YAG heads times head dimension times batch size. Option A. Only the vocabulary size. Option A. Only the learning rate. Option A. The screen resolution. The correct answer is V. Natch layer catches keys and values for every pass token and YAB head, so memory scales with sequence length, layers, YAB heads, head dim, precision, and batch size, motivating us by value and paging. Question 6. Thigh is weight tying between the input embedding and the output, unembedding, projection sometimes used. Option A. It reduces parameters and can improve generalization by sharing the token representation. Option A. It doubles the vocabulary automatically. Option A. It removes the need for attention. Option A. It encrypts the embeddings. The correct answer is V. 9. The input embedding matrix to the output projection shares parameters between mapping tokens to vectors and vectors back to logits, cutting parameter count and often aiding generalization. Question 7. Without positional information, self-attention is best described as Option A. Permutation equivariant, reordering inputs reorders outputs identically, losing absolute order. Option A. Strictly sequential like an array. Option A. Dependent only on token frequency. Option A. Unable to process more than 2 tokens. The correct answer is V. Self-attention treats inputs as a set, permuting tokens permutes outputs the same way, permutation equivariant. Positional encodings break this symmetry to convey order. Question 8. Which technique specifically reduce the memory by bandwidth cost of attention or its YAB cache? Select all that apply. Option A. Loyalty query by grouped query attention. Option A. Clash attention, neo-aware exact attention. Option A. Weighted YAB cache. Option A. Autoring the YAB cache in full Coco 3, 2 for every head. The correct answers are V and A. Lasso by Vaso, clash attention, page caches, and lower precision YAB all cut attention memory by bandwidth. Leaping a full precision cache for all heads maximizes memory use. Next section. Third fundamentals and tokenization. Question 9. Speculative decoding accelerates generation while preserving output quality because Option A. The verification step ensures only tokens consistent with the target model's distribution are accepted. Option A. It randomly outputs the draft model's tokens without checking. Option A. It trains the target model faster. Option A. It reduces the vocabulary size. The correct answer is V. The draft model proposes tokens that the target verifies in parallel. Accepted tokens match what the target would have produced, so speed improves without altering the output distribution. Question 10. According to Hinchilla style compute optimal scaling, many earlier large models were option A, under-trained, too few training tokens for their parameter count given the compute budget, option A, overtrained on far too much data, option A, too small to be useful, option A, trained without any data. The correct answer is V. Hinchilla showed that for a fixed compute budget, parameters and training tokens should scale together. Many prior models were too large and trained on too few tokens, undertrained. Question 11. That is in context learning in TIAS. Option A. The model adapting to a task from examples by instructions in the prompt without weight updates. Option A. Permanently updating weights from each prompt. Option A. A type of optimizer. Option A. A data storage format. The correct answer is V. In context learning lets a model perform new tasks purely from prompt content, instructions by examples, at inference time, with no gradient updates, an emergent capability of large models. Question 12. Which statements about decoding strategies are correct? Select all that apply. Option A. Greedy decoding can produce repetitive or suboptimal text. Option Top P and Top K restrict the candidate token set before sampling. Option Meme search trades compute for higher probability sequences. Option A. Temperature zero maximizes output diversity. The correct answers are V and A. Greedy can be repetitive, top K by top P truncate candidates, and beam search spends compute for higher probability outputs. Temperature zero minimizes, not maximizes, diversity. Next section. Prompt engineering. Question 13. In many chat models, how do system, user, and assistant roles typically interact? Option A. The system message sets overarching behavior by policy that should take precedence over user instructions. Option User messages always override system policy. Option Assistant messages are the model's training labels. Option A. Roles have no effect on behavior. The correct answer is V. The system role conveys high-level instructions and guardrails meant to take precedence. User turns provide requests, and assistant turns are the model's responses within that framing. Question 14. A practical downside of supplying many in-context examples, many short prompting, is Option A. It consumes more of the context window and increases token cost by latency per call. Option It permanently retrains the model. Option It reduces the vocabulary. Option A. It disables sampling. The correct answer is V. Natch example adds tokens, raising cost and latency and computing for limited context space. The benefit of more examples must be weighed against these inference time costs. Question 15. Which approaches can improve the reliability by consistency of die outputs? Select all that apply. Option A. Towering temperature for more deterministic responses. Option A. Providing clear instructions, schemas, and examples. Option A. Valve consistency via aggregating multiple samples. Option A. Leaving the task description ambiguous. The correct answers are V and A. Tower temperature, explicit schemas by examples, constrained decoding, and self-consistency improve reliability. Ambiguous instructions do the opposite. Next section. Fine-tuning to rev and pineapple. Question 16. After to rev fine-tuning, what does merging the adapter into the base weights achieve? Option A. It folds the low rank update into the original weights so inference has no extra adapter latency. Option It deletes the base model. Option It increases the rank to full automatically. Option A. It requires retraining from scratch. The correct answer is V. Because no-else update is the plus UI, you can pre-compute and add it into the, producing a standard model with no separate adapter, removing any runtime overhead from the adapter path. Question 17. Compared with full fine-tuning, a key trade-off of to-rev by pineapple is that it, Option A, greatly reduces trainable parameters and memory, sometimes at a small quality cost on hard adaptations. Option always strictly outperforms full fine-tuning on every task. Option requires more memory than full fine-tuning. Option I changes the model architecture permanently. The correct answer is V. Pineapple methods slash trainable parameters and memory and enable swappable adapters. For some demanding adaptations, full fine-tuning can still edge them out in quality, so it is a trade-off. Question 18. In which scenarios is pineapple, for example, to rev especially advantageous? Select all that apply. Option A. Limited upper memory relative to model size. Option leading many task-specific variants of one base model. Option A. Frequent low-cost iteration on adaptations. Option I. a hard requirement to modify every weight to maximum precision. The correct answers are N. Viper shines under memory limits, many task adapter scenarios, and rapid iteration. If you truly must update all weights at full precision, full fine-tuning is the fit. Next section, Python libraries for the miss. Question 19. In pipeline parallelism, what is the bubble that reduces efficiency? Option A. Idle time on some pipeline stages while waiting for activations from earlier by later stages. Option B. Memory leak in the optimizer. Option B. Bug in the tokenizer. Option A. Access vocabulary tokens. The correct answer is V. Splitting layers across stages creates startup by drain periods where some others sit idle, the pipeline bubble. Micro batching and interleaved schedules reduce, but do not eliminate, this overhead. Question 20. Thai is UTO 1.6 often preferred over COCO 1.6 for training large models despite having fewer mantissa bits. Option A. UTO 1.6 keeps COCO 3.2's exponent range, reducing overflow by underflow and the need for loss scaling. Option UTO 1.6 has more mantissa precision than COCO 1.6. Option UTO 1.6 uses 64 bits per value. Option A. UTO 1.6 disables the tensor cores. The correct answer is V. UTO 1.6 trades mantissa precision for a wide COCO 3.2 key dynamic range, making training more numerically stable and often avoiding the loss scaling tricks COCO 1.6 requires. Question 21. That does Torch.compile aim to provide in PyTorch 2.x question mark? Option A. Just-in-time graph capture and kernel optimization for faster execution with minimal code change. Option O. Automatic dataset labeling. Option B. Replacement for the WebDriver. Option A. B. New tokenizer. The correct answer is V. Torch. Compile traces and optimizes the model graph via backends like Torch Inductor, fusing operations and generating efficient kernels to speed up training by inference with little code change. Question 22. Which strategies reduce communication overhead in distributed training? Select all that apply. Option A. Gradient accumulation to communicate less frequently. Option A. Overlapping computation with communication. Option Y. Bandwidth interconnects, routing, and optimized collectives. Option I. Synchronizing every parameter after every single floating point operation. The correct answers are V, N. Gradient accumulation, compute by overlap, gradient compression, and fast interconnects by collectives cut communication cost. Rinsing after every op is pathologically inefficient. Next section, a video and training attack. Question 23. That is the purpose of video aligner. Option A toolkit for scalable model alignment, for example, RAFO by Copy within the video ecosystem. Option A thermal management utility. Option A spreadsheet macro engine. Option A configuration tool. The correct answer is V. Lido Aligner provides scalable implementations of alignment techniques, supervised fine-tuning, reward modeling, and EVO for customizing layers to human preferences. Question 24. An ABU Fopper by Vada Coco 8 support in denser array is used primarily to Option A. Accelerate inference and reduce memory with 8 floating point while preserving accuracy. Option A. Train models without any data. Option A. Increase the parameter count. Option A. Replace the tokenizer. The correct answer is V. Coco 8, supported by Fopper by Vada denser wars, speeds up the inference and lowers memory versus Coco 1.6 by Coco 1.6 with calibration by scaling to maintain accuracy, exposed via denser array. Question 25. How are denser array optimized models commonly served in production? Option A. Through the denser array backend in written inference server or packaged as a year. Option only by emailing the weights to users. Option A. By printing them to college. Option A. Exclusively anonymous with no. The correct answer is V. Denser array engines are typically deployed via Triton's denser array backend, handling in-flight batching, page jab catch, or packaged as RIA microservices for standardized web-based. Question 26. Which ABU components are commonly used to build an enterprise ABU system? Select all that apply. Option A. Lido retriever embedding and re-ranking models. Option A. RIA microservices for serving the TI and embedders. Option A. Vector database for storing embeddings. Option A. Spreadsheet macro as the primary retriever. The correct answers are V, N. An enterprise ABU on ABU commonly combines Lido retriever embeddings by re-ranking, RIA served TIs, and a vector database. A spreadsheet macro is not a viable retriever. Next section. Triton denser array and RIA deployment. Question 27. That does Triton's decoupled transaction mode enable for TI serving? Option A. Retrieving multiple partial responses, tokens per request as they are generated. Option A. Exactly one response per request only. Option A. Training the model online. Option A. Disabling the network. The correct answer is A. Decoupled mode lets a single request emit a stream of responses, which is how token by token streaming generation is delivered to clients in serving. Question 28. Designated by system shared memory between a client and return primarily helps by option A. Avoiding repeated copying of large input by output tensors over the network, reducing latency. Option A. Encrypting all model weights. Option A. Increasing the model's accuracy. Option A. Eliminating the need for a. The correct answer is A. Shared memory transport lets large tensors be passed by reference rather than serialized over the network each call, cutting data transfer overhead and latency for high throughput inference. Question 29. Why might a production DAI service implement request priorities and rate limiting? Option A. To protect latency barriers for critical traffic and prevent overload under bursty demand. Option A. To make the model larger. Option A. To delete user data. Option A. To disable batching permanently. The correct answer is A. Priority queues and rate limits ensure high priority requests meet latency targets and the system degrades gracefully under load, maintaining stability and fairness. Question 30. To achieve low latency by high sovereignty endpoint, which combination is appropriate? Select all that apply. Option A. Continuous batching with a page job cache. Option A. Bobo 8 by 8 quantization on supported AWS. Option A. Token streaming via decoupled responses. Option A. Merging each request on its own dedicated server with no batching. The correct answers are A and A. Continuous batching, quantization, efficient YAB caching, and streaming jointly deliver low latency and high sovereign. Then request per server with no batching scales poorly. Next section. AU and HIB application development. Question 31. The lost in the middle effect in long context is refers to what? Option A. Loaders often use information at the start by end of the context more reliably than content buried in the middle. Option the model deletes the middle of documents. Option A. They were losing data mid computation. Option A. Tokenization failing on long inputs. The correct answer is A. Studies show retrieval augmented models attend less reliably to relevant facts placed in the middle of a long context, so ordering and re-ranking retrieved chunks most relevant near the ends can help. Question 32. In AU evaluation, context recall specifically measures option A. Whether the retrieved context contains the information needed to answer the question. Option A. How fast they were run. Option A. The number of model parameters. Option A. The color of the name. The correct answer is A. Context recall assesses whether retrieval surfaced the necessary evidence. Context precision assesses how much of the retrieved context is actually relevant. Both gauge the retriever's contribution. Question 33. Which fixes address common AU failure modes? Select all that apply. Option A. Improve chunking and embeddings when retrieval misses relevant content. Option A. Add re-ranking and reorder context to combat lost in the middle. Option A. Instruct the model to answer only from provided context and cite it. Option A. Increase temperature to make answers more creative. The correct answers are A and A. Better chunking by embeddings, re-ranking, context ordering, and grounding instructions fix typical AU issues. Fire temperature undermines faithfulness. Next section. Data preprocessing and feature engineering. Question 34. Then training a new bit tokenizer, what is learned from the corpus? Option A. A vocabulary of merges by subwords based on frequency statistics of the training text. Option A. The model's attention weights. Option A. The optimal learning rate. Option A. The overclock speed. The correct answer is A. Where training scans the corpus and iteratively merges frequent adjacent units to build a subword vocabulary. The resulting merges by vocab are then used to tokenize text consistently. Question 35. Why is sequence packing used when preparing data for efficient training? Option A. It concatenates multiple short examples to fill the context window and minimize padding waste. Option A. It deletes long sequences. Option A. It encrypts the training data. Option A. It increases padding to slow training. The correct answer is A. Backing fits several short samples into one fixed length sequence with proper attention masking by separators, so hubs spend compute on real tokens instead of padding, improving throughput. Question 36. Then building an instruction tuning dataset. Why is consistent formatting, for example, clear instruction by response delimiters, important? Option A. It helps the model learn the input-output structure and follow instructions reliably. Option, it increases the open memory. Option, it encrypts the labels. Option, it guarantees zero loss. The correct answer is V. A consistent template teaches the model where instructions end and responses begin, improving its ability to parse prompts and produce well-structured, instruction-following outputs. Question 37. That is a responsible way to handle personally identifiable information in a training corpus. Option A, detect and redact or remove as part of data curation. Option A, deliberately amplify so the model memorizes it. Option A, ignore it entirely with no review. Option A, encrypt the hub. The correct answer is V. By handling detection, redaction, removal, or anonymization reduces the risk of the model memorizing and leaking sensitive personal data, supporting privacy and compliance. Question 38. Which practices improve the quality of entire pre-training by fine-tuning dataset? Select all that apply. Option A, reduplication and decontamination. Option quality by toxicity filtering and redaction. Option balance coverage of relevant domains by languages. Option A, injecting large amounts of random noise as gold labels. The correct answers are V and A. Deduplication, decontamination, quality by toxicity filtering, query redaction, and balanced coverage raise data quality. Creating random noise as gold labels harms training. Next section. Experiment design. Question 39. A model improves offline metrics but fails to improve the live business after deployment. This most likely indicates option A, a mismatch between the offline metric by data and real-world online conditions. Option A, that offline evaluation is always useless. Option A, that the open is broken. Option A, that the model has no parameters. The correct answer is V. Offline-online gaps arise from distribution shift, proxy metrics that don't track the UI, or feedback effects. Bridging them needs representative data and online mobile validation. Question 40. Wimson's paradox warns that option A, a trend visible in aggregated data can reverse when the data is split into subgroups. Option A, low data always reduces error. Option A, models cannot be compared. Option A, however, slow down with more cores. The correct answer is V. Wimson's paradox occurs when aggregation hides or reverses subgroup trends, often due to a confounder, so segment-level analysis is essential before drawing conclusions. Question 41. Fitting a scalar, for example, a standard scalar, on the entire dataset of splitting into train by test causes what? Option A, data leakage. Test statistics influence the training preprocessing. Option A, faster overtraining with no downside. Option A, larger vocabulary. Option A, automatic hyperparameter tuning. The correct answer is V. Preprocessing parameters must be learned on the training split only. Fitting on all data lets test set information leak into training, producing optimistic, invalid estimates. Question 42. Which conditions are necessary for a fair comparison between two models? Select all that apply. Option A, evaluating both on the same held out test set. Option A, using the same preprocessing and metrics. Option A, controlling for randomness, seeds, or reporting variance. Option A, letting one model peek at the test labels during training. The correct answers are V and A. Where comparisons use identical test data, preprocessing, and metrics and account for randomness. Allowing one model to see test labels is cheating. Next section, nodal evaluation and metrics. Question 43. A known issue when using a strong die as an automatic judge is option A, biases such as favoring longer answers or the first option presented, position bias. Option A, it cannot read text at all. Option A, it measures over temperature. Option A, it requires no prompt. The correct answer is V. As judge can exhibit verbosity bias, position bias, and self-preference. Mitigations include randomizing order, controlling length, using rubrics, and calibrating against human labels. Question 44. The pass-at metric is commonly used to evaluate which capability? Option A, mode generation, probability that at least one of sample solutions passes the tests. Option A, image resolution quality. Option A, urban memory bandwidth. Option A, vocalizer vocabulary size. The correct answer is V. Pass-at estimates the chance that at least one of generated programs passes the unit tests, a standard measure for code generation models, for example, on human level. Question 45. Thai can by NLP port proxies for evaluating open-ended responses. Option A, they reward n-gram overlap with references and miss semantically correct paraphrases. Option A, they require a to compute. Option A, they only work for images. Option A, They measure latency. The correct answer is V. Burfess overlap metrics penalize valid paraphrases and can judge reasoning, helpfulness, or factuality, so open ended generation also needs human or model based semantic evaluation. Question 46. Which methods are appropriate for evaluating a EU system specifically? Select all that apply. Option A. Faithfulness by groundedness of the answer to retrieved context. Option context precision and context recall of the retriever. Option answer relevance to the user's question. Option I. Counting how many of us served the request. The correct answers are V and A. EU evaluation spans retrieval, context precision by recall, and generation faithfulness, answer relevance. Above counts are unrelated to answer quality. Next section, data analysis and visualization. Question 47. That does an empirical cumulative distribution function plot show? Option A. The proportion of data points less than or equal to each value. Option only the single mean value. Option A. The model's architecture. Option A. The utilization over time. The correct answer is V. When Yamuk steps up from 0 to 1, showing the fraction of observations at or below each x value, useful for comparing distributions and reading percentiles without binning choices. Question 48. Why can a chart with two different y-axes, dual axes, be misleading? Option A. The independent scales can imply correlations or relationships that are artifacts of axis choices. Option it is impossible to draw two lines. Option it always shows causation correctly. Option A. Dual axes increase model accuracy. The correct answer is V. Dual axis charts let you rescale each series independently, which can manufacture apparent alignment or divergence. They should be used cautiously with clear labeling or avoided. Question 49. Which is a good accessibility practice when designing data visualizations? Option A. Less colorblind friendly palettes and don't rely on color alone to convey information. Option encode all meaning using red versus green only. Option remove all axis labels for a cleaner look. Option I. Is the smallest possible font. The correct answer is V. Accessible charts use colorblind safe palettes, redundant encodings, shaped by labels by patterns, sufficient contrast, and readable fonts so information isn't lost for color vision deficient viewers. Question 50. Which practices help when visually comparing distributions across groups? Select all that apply. Option A. Overlaid or faceted histograms by Youngnas. Option box or violin plots side by side. Option using consistent axes by scales across panels. Option I. Using different arbitrary scales per group to exaggerate gaps. The correct answers are V and A. Faceted by overlaid histograms or Youngnas, side by side box by violin plots, and consistent scales aid honest distribution comparison. Arbitrary per group scales distorted. Next section, AVM and accelerated data machines. Question 51. Neo supports open accelerated string operations. Why does this matter for the pipelines? Option A. Next cleaning by tokenizing of large datasets can be a bottleneck that the open accelerates. Option the strings cannot be processed on obras at all. Option it converts strings into obras. Option A. It removes the need for any text data. The correct answer is V. Any pipeline spends significant time on string manipulation, cleaning, splitting, rejects. When Java string functions speed up these steps within an end-to-end accelerated workflow. Question 52. Avilio Lerlin by Tabular targets which workload? Option A. About accelerated feature engineering and training for recommender systems on tabular data. Option A. Real-time speech synthesis. Option 3. A game rendering. Option A. Email spam filtering only. The correct answer is V. Tabular, part of Avilio Lerlin, accelerates large-scale tabular feature engineering and data loading for recommender system training, handling datasets larger than open memory. Question 53. In which case might Hubbard-based pandas be preferable to Hubbard? Option A. Small datasets or workflows where Hubbard transfer by launch overhead outweighs the speedup, or no Hubbard is available. Option always regardless of data size. Option only for datasets larger than 1 no. Option N. Wherever pandas has no valid use. The correct answer is V. For small data or environments without a suitable Hubbard, pandas avoids Hubbard overhead and complexity. Logos advantage grows with dataset size and parallelizable operations. Question 54. Which statements about the Librarian ecosystem are accurate? Select all that apply. Option A. It is built on the Apache row columnar format. Option and graph cover data frames and graphs. Option it can scale across multiple hubs by nodes with gas. Option A. It only runs on hubs and never uses hubs. The correct answers are N. Erbium uses Vero, provides log by graph, and scales via GASC. It is specifically designed for urban acceleration, not urban only execution. Next section, alignment and error. Question 55. The alignment tax refers to what? Option A potential drop in some capabilities by helpfulness as a model is made safer by more aligned. Option a monetary fee charged by regulators. Option the electricity cost of a Option a type of tokenizer. The correct answer is A. Alignment tax describes cases where safety tuning, for example, heavy refusal behavior, slightly reduces helpfulness or benchmark performance. Good alignment seeks to minimize this trade-off. Question 56. Reward model overoptimization of Woodhart effect in LAFO occurs when Option A. Pushing too hard on the proxy reward degrades true quality even as measured reward rises. Option A. The reward model is never used. Option A. The tokenizer changes mid-training. Option A. The human runs out of power. The correct answer is A. Because the reward model is an imperfect proxy, optimizing it too aggressively, Woodhart's law, can improve the metric while harming real human judged quality. It penalties and early stopping help. Question 57. Which measures help mitigate reward hacking by overoptimization in LAFO? Select all that apply. Option A. Violate penalty keeping the policy near the reference model. Option improving and periodically retraining the reward model. Option A. Monitoring with human evaluation, not just reward score. Option A. Maximizing reward without any constraints or checks. The correct answers are A and A. Led regularization, better by refreshed reward models, and human in the loop monitoring counter reward hacking. Non-constrained reward maximization makes it worse. Next section, trustworthy way ethics, ways and safety. Question 58. That is the goal of watermarking or content provenance for generative way. Option A. To help identify the generated content and trace its origin. Option to speed up model inference. Option to increase the parameter count. Option to compress the dataset. The correct answer is A. Watermarking and provenance standards, for example, sending or embedding detectable signals by metadata, aim to flag the generated media and establish origin, supporting transparency and misuse detection. Question 59. That is data poisoning as a security threat to the models. Option A. Injecting malicious or manipulated examples into training data to corrupt model behavior. Option A. Spilling liquid on the Option encrypting the model for safety. Option A. Reducing the learning rate. The correct answer is A. Data poisoning manipulates training or fine-tuning by data to implant backdoors or biases. Defenses include data provenance, vetting sources, filtering, and anomaly detection. Question 60. Which are sound governance by responsible way practices for deploying layers at scale? Select all that apply. Option A. Maintaining documentation, model by data cards, and clear intended use policies. Option human oversight and the ability to intervene or roll back. Option A. Ongoing monitoring for bias, drift, safety, and misuse. Option A. Deploying with no logging, review, or accountability. The correct answers are A and A. Responsible governance includes documentation, human oversight, monitoring, access controls, and accountability. Deploying without any oversight is the opposite of responsible way. That completes the practice test. Review the explanations for any questions you missed, and good luck on your certification exam.